This is a question on under logs and exponential function. If I talk about part A, so solve the following equation. So in that case, so for part 1, we need to solve this exponential equation. So we have it as 5 into e to the power of 3x plus 4 is equals to 14. So whenever we want to make something which is in the power of the subject, we should always think about applying the ln on both the sides because we have this natural constant e. So that is the reason we have to think about applying natural logs, which is ln. So before applying it, let me send this 5 to the other side. So it's going to be e to the power of 3x plus 4 is going to be equals to 14 over 5. If I apply ln on both the sides, so it's going to be ln of e to the power of 3x plus 4 is equals to ln of 14 by 5. And here, clearly, so we know this law of logs, which goes something like whenever we have ln of m power n, this thing can also be written as n times ln of m. Keeping this law in mind, so if this 3x plus 4 can come in the front of ln, so it's going to be 3x plus 4 multiplied by ln e is equals to ln of 14 by 5. And here, the value of ln e is going to be just 1. So that's going to give us just 3x plus 4 is equals to ln of 14 by 5. So from here, we can make x the subject. So it's going to be 3x is equals to ln of 14 by 5 minus 4. And in that case, x would be equals to ln of 14 by 5 minus 4 divided by 3. This is the exact answer. If we put the same thing in the calculator, we can also get the answer something like negative 0.99. And this is the right answer for A part 1. Now, if I talk about A part 2, we need to solve for y here. So in order to do this, the first thing that we should be knowing is whenever we have log, LG is another way of writing log. So whenever we have log m plus log n, that can also be written as log of m times n. So now keeping this law of log in mind, so if I combine these two, so that's going to be log of 2y minus 7 multiplied by just y is equals to, now this 2 I can take it inside this log, so using this property. So if I have log of m power n, that thing can also be written as n times log of m. So I can also do the reverse thing. If I have n times log of m, I can also write it as log of m to the power of n. So in that case, it's going to be log of 3 squared. So now whenever I have log of x is equals to log of y, so we can just equate those things. So that's going to be 2, when I expand this one, so it's going to be 2y squared minus 7y is equals to 3 square is 9. So here we will be getting a quadratic equation, and the quadratic equation is 2y squared minus 7y minus 9 equals to 0. And this is what is the quadratic equation we have it. So from here, if I think about solving for y, so and since we can use the calculator, we can directly solve for y using the calculator. On the calculator, so if we go to a quadratic polynomials, so which is nothing but polynomial tools, finding the real roots of quadratic polynomial, yes, degree is 2, and the coefficient of x squared here, it is y has to be 2, then it's minus 7, then we have minus 9. And the two possible values we will be getting here is, so either we will be getting y as negative 1, or we have y as 9 over 2. So 9 over 2 is nothing but 4.5. So here the value of y cannot be negative 1, because if y is negative 1, so we will have it as log of negative 1, and log of negative 1 does not exist. So y cannot be negative 1. So that's why the final answer for part 2 has to be just 9 by 2, which is nothing but 4.5. And that is the right answer for part 2. Next, if I talk about part B, So we need to write down this one as a single logarithm with the base of 2. So in order to do that, so first of all, if I talk about the numerator, so we need to be aware of this property. Whenever we have log of m minus log of n, this thing can also be written as log of m over n. Of course, we need to have the same base, only then we can combine it. So in that case, the numerator we can combine it as log of p by q over 2. And entire thing divided by. So now this thing log of r to the base 2 can also be written as, we have something like a change of base rule. So whenever we have log of a to the base b, we can also write this one as log of a to the base c over log of b to the base c. So c could be any base. So in that case, if I change this one, so this thing can also be written as log of r to the base 10. 10 we cannot, we can also just skip writing it. If there is no base for log, it is considered to be 10. So log of r over log of 2 multiplied by, similarly, if I have log of 2 to the base r, that thing can also be written as log of 2 over log of r. So here these things can get cancelled out. And that's going to give us the denominator as 1. So that is the reason the final answer for part B has to be log of p over q to the base 2. And this is the right answer for this one.